Hello, this is Chris from Visual Components, and today we're going to have a look at the safe operation configuration that you can do with the KUKA.sim add-on in Visual Components Premium. For that, we're first going to go to the File tab, have a look at the options and add-on, where we can see that actually our KUKA.sim add-on is enabled. If this is not the case, you might need to restart the application. But since this is done, we can already have a look at the general options and look at our controller version. That should be the identical one as your KUKA robot is currently using if you want to transfer the safe operation configuration to the real robot later. As this is all set, we can now go to Home and to the eCatalog, to Components, and look for our KUKA robots. So we go to the KUKA folder here, way down to the robots and to the high payloads, and I will select a KR120 here and generate it in the origin of our simulation. Now that we have a robot, we still need some other things. For example, we will go to the Visual Components folder and here go to the robot tools and add this suction cup gripper to our layout. And with PNP, we're going to put it onto our robot. In addition to that, we will need some facilities. So if we go to the facilities factory and we're going to add a generic fence on the one side of the robot, just going to drop it here. And we're going to use some machines. So this coordinate measure machine on the other side of the robot. And I'm just going to rotate it by 180 degrees so it's facing the other direction. Great, now that we have our little setup, we can proceed by just saving the layout real quick. And I will just overwrite this version 1. Great, now that this is done, we can continue with the actual configuration. So for that, we need to be in the Home tab and then go down to Devices. And in this Devices, you can see the whole tree of our KUKA controller with the robot, some field bus configuration that you might add, or also the safety configuration. If I click on that, you can see on the right side that the properties are opening up, and I need to select the Safe Operation product here in the Safety Product option. Now you will see that this gray cube is generated in the simulation. We still need to activate the whole safety monitoring, so we will just tick the box here and our cube will turn green, meaning that we can now use it properly. This green cube is also the one that we're going to start with. This is the cell configuration, so it's actually the outer cell limits that we have. And we can change here the size. So it's always in reference to our $world. And here we can now change the height, maybe to only 4 meters. And then if we go to the move manipulation mode, and click on the first corner that we have, we will see that the frame appears on the corner of this corner 1. And now we can actually drag and drop it into the position, or we can change the values according to our requirements that we might have from our designer or layout. And here then we can go to the corner number 2. And actually also drag and drop it into the place. Same for corner 3. And the last one, corner 4. You can also use the snap functionality. And if you want to add a corner, you can just click on this plus corner on the bottom. And it will generate a new corner in the $world of the robot. And thus it is not anymore a convex shape, we have to change again the corner until it gets green. And here we are. So now we have a working layout. Great. As we have done that, we can now click here on the little eye, so to make the whole cell configuration invisible, and proceed with the configuration. And this is very close now to the things that you might know from WorkVisual. So all the settings can also be done here with the KUKA Sim add-on. Here we can change the maximum velocity of Cartesian velocity monitoring or some axis velocities. You might have some requirements from your company with some different values that you have to put in here. I will go with the default values. Same goes for the axis monitoring. You can also change the monitoring here depending on what is your requirement from your company. Here I will also just leave them as default. What is more important to me right now is the tools. So these are also things that I can configure here. If I click on plus, I already see that I have one tool. So it's the yellow sphere here that has been added. And as I clicked on it, I can now actually change the TCP of the tool. So I can drag it further up here until the front of the suction cup, somewhere like there. So it will be the place where there is the velocity monitoring coming from. In addition to that, I can now here change the sphere that has been predefined. So it's already been activated, but I can now reduce the size to maybe 100 millimeters and also change the position, either snap it to a certain point with the snap tool here, maybe here to the corner of the gripper, or I can move it around with this move operation mode. And I will set it such as the suction cup is still inside of the sphere. Next up, I'm going to add a new sphere, and you will see that it's not yet been activated. So we'll do just that by clicking here the tick in the box, and it got yellow. So now I can use it properly. Again, I will change the size to 100 millimeters and snap it to the next corner here. Again, moving it so that all the suction cup is nice in, but it doesn't take too much space around it. And I will repeat that for every single corner of my tool here. So again, I will snap it to the corner here, change the size to 100 millimeters, and also change the position such as that the cup on the bottom right is just in the sphere. And a last sphere here, so the sphere number 4, also reduce it to 100 millimeters and snap it to the other side here. Great, now that we're set, we can continue and we can actually add another tool here by right-clicking, add a new tool. But at the moment I just have this suction gripper tool, so I don't need another tool. But I can proceed with my monitoring spaces. So in this case, I can also right-click on them and add a new Cartesian space. It will add me this space number 1, which I could rename. So for example, fence. And define it as a protected space. So you have different kinds of spaces. For example, here this X-specific space, you have an X-specific protected space, you have an Cartesian workspace, or you have a Cartesian protected space. And this is the one that I'm going to choose. So it changed a little bit the color. And now I can snap it again to the fence that I have here, so the foot of my fence. And I can change the position a little bit, maybe something like that. And now change also the size. So in X, it's going to be 2500 millimeter. In Y, it's going to be about 40 centimeters. And in Z, it's also going to be 2500 millimeters so that I cover my whole fence. And I will add another monitoring space by right-clicking here and adding a new Cartesian space. And if I select that one, I will also set it to a protected space, call it machine, and now drag in and drop it to the other side here of my machine, leaving a little bit of space. And then again, make it a little bit taller, maybe 2 meters, to actually properly wrap my machine here. I could also continue here with the next point, which is a reference position. I could now teach and touch up a new reference position. This is very useful if you want to check out that the reference position is nicely positioned. And you can make this test up front in KUKA Sim. We can do this in a showcase if I go to Program and jog the robot around to a place that I think I might use as a reference position. I'm thinking about maybe here the lower point of my machine. Somewhere like that. And I now go back to the Home tab, Devices, and go to my reference position. I can see the current position of the robot, and I can see that it's not in the tolerance of 5 degrees around the 0 position. And thus I can use this position to touch up my reference point. Now we can just reset here the program or the robot into the home position. And we can start with a little program where I will go with my tool from one side, almost touching the Cartesian protected space. We'll just do a PTP movement here to the other side. And doing another PTP movement here. And I'm just going to bring my home position to the other side. And if I now run the program and in the same time collect my data, and if I have a look at my trace settings and just play the program once, it will now move. And it will actually now move very slow. And I can see that it almost comes to a halt. And it will give me this message, Safe Robot Override Reduction Active. But it will not completely stop and go to the other side. And here the point is too far away from the protected space, so there is no real reduction. If I now go to my trace analysis, I can have a look at the braking before restricted area value with the override in percent, which is going to be shown if I select the trace diagram. And if I look and make it a little bit bigger here, the output, or zoom out and move back in time, I can see that here at the start, the override was 100%. Then it came here to a near stop, but it continued with 1%. So if I visualize the whole thing and go back to home and make the tool visible and go to the orthographic view, you can see that one of the spheres actually entered in my protected space, which is not my goal. But I can see this here in the program diagram output that the braking before restricted area is 1%. All the way until it goes back and accelerates again here on the right side and goes all the way back to the other point where nothing happens and now goes back to the home position. In other words, even though I contacted this protected space, the robot didn't stop, which is not the same as in a real robot system. This is because the robot actually has no information about the way that the robot will stop in a stop zero situation. So in this case, we have to go back to the home, and now here in the safety configuration to the braking before restricted area, and we can activate this BBRA functionalities. And if we now continue and press play, the robot will brake earlier and come to a full stop until I get the message. The continuation of the motion is blocked by monitoring range, and we have a braking before restricted area override of 0%. In other words, if we have now a look at our program and the diagram there, we can see that the override reduction is at 0, so the robot is not moving anymore. So we can now adapt our point. If we reset the program, go to jog, click on our point number 1 and put it a little bit further away. Touch up this point. And the other point is actually not close enough to see a real impact. So I'm going to go a little bit closer, something like that. Touch it up also. And reset it and have another look. We have a reduction here also, and the robot goes back to home. So if we check out the BBRA path in the tracing, we can actually see that at the beginning there is no reduction. Then we reduce the speed when we come closer here to the protected space. Then it returns actually, and we have a full-blown acceleration again to the other side. And then back home. So here we have deacceleration again for 0.2, and then on the way back into home position, there is no reduction anymore. So we can see that actually this braking before restricted area works well, and we can now adapt our protected spaces depending on the cycle times that we want to achieve and how this will work out. There is another nice functionality that enables me to see and to simulate the stop 0 and the stop 1 spaces. In this case, we can use this KUKA stop service here, and it will give us some options here. We can define a start and an end position. We can also define a tool. In this case, it's our tool 1. And if we now press on play, we will get a generated big spheres around our tool where you can expect the robot to go in the case of a stop 0 and stop 1 brake. So in this case, I would need to move my fence further away from the robot in case of a stop 0 that there is no impact. Same goes for the machine. If I don't want it to be impacted, if there is a stop 0 or stop 1, I must move it further away. There is one last functionality that I want to show you. It's again the export to WorkVisual. So if I go back to home and here say export project and export, and now go to my documents, visual components 4.8, my project, I will have the KUKA SimSafe operation project from WorkVisual. And if I double click on that, it will open WorkVisual. And now once the project is open in WorkVisual, we can go onto our KRC5 cabinet, activate it. And now that we have opened our WorkVisual project, we can go on our KRC5 cabinet, double click on that, go to the safety control and double click on this. And here we will find exactly the same settings as we just did in Visual Components with the KUKA Sim add-on. So we will have our monitoring spaces, so the fence and the machine. We will have the defined places in our layout. We'll have also the settings for the tools. So we first have the one tool here, and I can have a look also at the spheres that we set. We can have a look at the activation of our braking before restricted area and at our reference position. So everything is already set, and now you're good to go to actually commission the robot and to transfer the configuration onto the controller. I hope that this was useful. I hope that you liked this view of the braking before restricted area and the safe operation configuration with the export to Workvisual. And I hope to see you again in the next video. Bye!